Dear students, let's continue our practice on Mathematical Analysis 1. Today we'll talk about the principal part of the function with respect to test function. Let's consider the first example. Find principal part of the function f of x is 1 minus cosine 2x cubed. With respect to test function x, as x tends to 0. So, how to find principal part of this function f of x? Let me give a little definition to principal part. It is limit as x tends to x0. So x, in this case, x0 is 0. So f of x over such kind of p of x, this is principal part, should be equal to 1, and p of x is in the form such kind of constant times this g of x, test function, the power of alpha. This one we call principal part of this function, p of x. So now, in this case, we have as f of x the function 1 minus cosine 2x cubed. So, we know 1 minus cosine x is, from fundamental limits, equivalent to 1 over 2x squared. Or we can write cosine x is equivalent to 1 minus 1 over 2x squared. So, if we use this equivalency, we have this one, 1 minus cosine 2x cubed. So here, now, instead of x, we have 2x. If you put 2x here, if you put 2x cosine 2x is equivalent to 1 minus 1 over 2 times 2x squared, or 4x squared, or just 2x squared. So, and now let's write this, let's use this equivalency, and we have it is equivalent to 1 minus 2x squared, this one, cubed. So, now, if we continue, if we open these brackets, we have it is equivalent to 6x squared. If you open these brackets, we have here 1 and minus 1, they are cancelled, and 6x squared, the next term will be minus 12x fourths, and plus 8x 6 degree. So now, let's find principal part. Should be limit x tends to 0. Now, in our case, f of x, instead of f of x, we can put this expression 6x squared minus 12x fourths plus 8x 6 degree over p, and it should be equal to 1. and our px, in this case, it is with respect to function of x, this test function, as x tends to 0. So in this case, p of x is equal to 6x squared. And in this case, we get 1. So our constant is 6, alpha is 2. So the ratio should be 1, and it will be 1 if only if p of x is 6x squared. So the answer, principal part of the function, is 6x squared. Let's consider the next example. Again, find the principal part of the function f of x. Let me write the function f of x. It's equals to logarithm e plus 3 over x minus 1. With respect to test function, 1 over x, this is g of x, it is 1 over x, as x tends to infinity. So, how to find the principal part of this function, f of x? So we will use the corollaries of second fundamental limit. So what we have logarithm, the base of a, 1 plus x, it's equals to 1 over logarithm a times x plus small o of x. So we will use this equality. Use the Landau symbol, small o. It means the ratio of these two functions is, if x tends to 0, it is 0. If x tends to 0 here, as x tends to 0. Now, using this equation, we have the following one. F of x now equals to logarithm. If we so we can write here like logarithm and do out of the bracket this number e, and we get 1 plus 3 over e times x. Yes, minus 1, of course. And now we have logarithm e, so it is, we can write the multiplication as logarithm e plus logarithm 1 plus 3 over e to the power e times x and minus 1. So logarithm e is 1. So they are cancelled. And we have just logarithm 1 plus 3 over ex. And using this one equation, it's equivalent with 3 over e times x. So now what is our principal part? This is this one. This one is now our p, principal part of this function. Because if we compute the limit f of x over p of x, it is 1 because they are equivalent. And when two functions are equivalent, one more time, let's recall, f of x and g of x are equivalent if the limit x as x tends to a, for example, x tends to a, f of x over g of x is 1. So in this case we get the same one. So however they are equivalent, it means the ratio is 1, and it means this function is our principal part of f of x. Let's consider the next example. Find the principal part of the function f of x is square root of 1 plus 3x minus square root of 7. With respect to test function, g of x is x minus 2 as x tends to 2. How to find the principal part of this function? So we can use this limit, this property. So 1 plus x, if you remember, 1 plus x the power of alpha. This is again the corollary of second fundamental limit. It's equals to 1 plus alpha times x plus small o of x. So we will use this equation here, of course, x as x tends to 0. So let's rewrite f of x. F of x is, we have 1 plus 3x minus square root of 7, and we can write this first square root as 7 plus, if we take out 3x minus 2. We need to find with respect to our g of x, and we should to provide to g. So, and of course minus square root of 7 we have. If we continue, it is square root of 7. You can take out this square root of 7, and we get here in this square root we have 1 plus, so 3 over 7 times x minus 2 minus square root of 7. Why we need this one? Because we need to use this equation. We want to use this equation. And to use this equation, you need to provide to this form. So now we have, so it is 1 plus 3 over 7 x minus 2 the power of 1 over 2. This is our x as x. This is just coefficient. So we get the next one. If we continue this one, square root of 7, or we can write without this small o as equivalent. It gives to us equivalency, and square root of 7. So here we have 1 plus alpha times x, so it is 1 over 2 times 3 over 7 x minus 2. 3 over 7 x minus 2. And close the brackets. And minus square root of 7. Square root of 7. So if you simplify this expression, you get the next one. So it is what we have here. If we open, look here, square root of 7 minus square root of 7, they are cancelled. Get this one. Let me write. Square root of 7 plus 3 over 2 times square root of 7 x minus 2 and minus square root of 7. They are cancelled, and we have just 3 over 2 times square root of 7 times x minus 2. This is our principal part, equal to p of x. This is our principal part function with respect to test function g of x, principal part of f of x, as x tends to 2. So I think it's clear with principal part of the function. And now we'll move to the next section. Find the asymptotes of the function with limits. Finding asymptotes of the function using the limit. So consider the following function f of x, where x is not equal to 0, and find the domain of definition and the limit for x tends to 0 plus minus, so it means one-sided limits at the point 0, and the asymptotes of this function. So how to find the domain of this function? To find the domain of this function, it is, in this case, it is 3. The denominator is not equal to 0. So, or, if you take out the x, it is x, 3x plus 19 is not equal to 0. It is x is not equal to 0, and x not equal to minus 19 over 3. So this is domain. We can write domain as domain of f, or just df notation. We have different notations. It is r minus this one, 0 and minus 19 over 3. It means in all other points the function is defined, except this 0 and minus 19 over 3. And if we will not consider the point 0, if we give a definition as x is not equal to 0, so the except point is only minus 19 over 3, and it will be vertical asymptote for our function. And how to find this vertical asymptote? This is very easy. Limit as x tends to this x0. Let's denote by x0. It is f of x should be infinity. So if you put here minus 19 over 3, so limit x tends to minus 19 over 3, our function tends to infinity. Here we can consider the plus minus, so one side and left side limit. Here we have plus infinity and minus infinity. So this is vertical asymptote. And now let's consider this function. This is if we find limit when x tends to as x tends to 0 plus minus this function, it is limit x tends to 0 plus minus. So x fourth plus 5x squared plus sine x over 3x squared plus 19x. So it is or just let firstly use the equivalency of the sine x. Let just it is f of x, and it is equivalent to, we can change the sine x with x because they are equivalent. So we have x fourth plus 5x squared plus 1 over 3x squared plus 19x. So here, if we divide by x, you can continue it. It is equivalent to x cubed plus 5x squared plus 1 over 3x plus 19. So as x tends to 0. And now the one-sided limits of this function, limit x tends to 0 plus minus f of x. Here we can see if it is tends to 0, 0 plus 0 plus 1, 0 plus 19, it's just 1 over 19. We have limit as x tends to 0 plus minus. So we found domain of this function. We found the limit as a one-sided limit at the point 0 and one vertical asymptote, and the last one is left or right asymptotes. So as x tends to plus minus infinity. To find left or right asymptotes, it should be limit x tends to plus minus infinity. F of x over x should be the finite number k, and then we can find this asymptotes left and right asymptotes. Here in our case, let's find f of x over x. It is limit x tends to plus minus infinity. F of x over x, it is x cubed plus 5x squared plus 1 over 3x squared plus 3x cubed, here 4th degree. Yeah, the given one is 4th degree. X fourth 5x squared and plus sine x. Here just x, sorry. In this case just it doesn't matter, and we get this answer. So sine x 3x squared plus 19x, and when we multiply by x, the denominator, we have 3x cubed and 19x squared. But you can see the power of numerator is bigger than the power of denominator. That's why in this case we get the infinity, plus infinity. So we don't have finite limit. That's why we don't have the right and or left asymptotes as x tends to plus minus infinity. So one more time, the domain of this function is this one, r minus 0 and minus 90 over 3 minus, here if it is visible, it is minus r minus 0 minus 90 over 3 and 0 and minus 90 over 3. The one-sided limits at the point 0, it is minus 9 not minus, just 1 over 19, this one. This is one-sided limit. And asymptotes, we have one asymptote, just it is minus 19 over 3, x equals to minus 19 over 3. It is vertical asymptote. And we don't have left or right asymptotes. Okay, if we do small changes in our example, for example, let's consider now as f of x it is x fourth degree plus 5x squared plus sine x, but in denominator we have, for example, 3x not squared, now cubed, plus 19x. X not equal to 0. And in this case, our denominator is not equal to 0 for all x which is not equal to 0, because if we consider the denominator, it is x squared, x 3x squared plus 19, and this is always positive, and our x is not equal to 0, so the just x is not equal to 0 we get here. So the domain is df is R, the set of all real numbers, minus the set of 0. Okay, now our f of x is, again, we can see it tends to, limit of this function is tends to, as x tends to 0 plus minus f of x tends to, again, 1 over 19. We can see it doing the previous operations. And now find this limit x tends to plus minus infinity f of x over x f of x over x. It is this is k. We need to find oblique asymptote y kx plus b. You need to find this one, this straight line. This is oblique asymptote. For example, if we have the function such kind of, for example, like this one and like this one, the oblique asymptotes will be, for example, this line, straight line. So this is oblique asymptote of our function. Okay, now this is k, and our k is, if we divide now by x fourths plus 5x squared plus sine x over now 3x fourths plus 19x squared now. And now if you divide by x, it is, if you compute this limit, it is 1 over 3. Because we have same degrees, the polynomials. So this is 1 over 3, it is our k. Now we need to find our b. To find b is f of x minus kx. This is b. You can see here it is just f of x. This one is f of x minus kx, and it should be tends to 0 as x tends to plus minus infinity. If it is 0, our b is 0. And in our case, it tends to 0. You can see here, if we subtract from f of x, so x first degree plus 5x squared plus sine x over 3x cubed plus 19x minus x over 3. In our case, it tends to 0, and then we have b is 0, because you can see it is as x tends to plus minus infinity. Here we need to do in common denominators. Here 3, here 19x. So the x4, 3x4 we get here, and they are cancelled, and we have just this one. So let me write here. We have minus, if we subtract, minus 4x squared plus 3 sine, because it's 15 minus 19x squared minus 4x squared plus 3 sine x over 3 times 3x cubed plus 19x. So the degree of the denominator is bigger than the degree of numerator, so it tends to 0 as x tends to plus minus infinity. So our b is 0. So our oblique asymptote is y is just kx. So k is 1 over 3. This is k. So this is 1 over 3, and the answer is just 1 over 3x. This is oblique asymptote. So here we don't have vertical asymptote because x is not equal to 0. It's given one. And we have just right and left oblique asymptote. We can say we call it right and left oblique asymptote for x tends to plus minus infinity. And why we call it is left and right oblique asymptote, because if we draw the picture, let me draw here the picture is so x over 3, this is straight line, yeah, for example this one, it is x over 3, and our graph is going through this line, and it will be like this. So it is our graph. This one. So that's why we call it left and right oblique asymptote. Let's do one more example. So again, find the right and left asymptotes of this function. So let's begin with k. So what was the key? Limit x tends to plus minus infinity f of x over x. So in this case, if we divide by x, this one is limit x tends to plus, as x tends to plus minus infinity, x fourth plus x squared plus 2x times sine x over multiplied by x, it is 4x fourth now plus x squared. So if x tends to plus minus infinity, it tends to 1 over 4. So now let's find b. So b is f of x minus kx, k times x. So now let's consider the difference f of x minus kx. So it's equals to, we need to give a common denominator here. So it is x fourth plus x squared plus 2x times sine x over 4x cubed plus x and minus x over 4. And they give a common denominator. We have here the difference is 4x fourth plus 4x squared plus 8x sine x minus 4x fourth minus 4x squared. So x squared, just here x squared, and then we have here 4 times 4x cubed plus x, and let's compute it. So it is, they are cancelled, x fourth and x fourth. We have 3x squared plus 8x sine x over 4 times 4x cubed plus x. So now the power of denominator is again higher than the power of numerator. That's why as x tends to plus minus infinity, it tends to 0. So it means b is 0. The oblique asymptote of our function is kx plus b, and we have b is 0, y is kx. and kx, it is x over 4, because k is equal to 1 over 4. This is k. So we have the answer x over 4, and x over 4, it is right and left oblique asymptote for x tends to plus minus infinity. This is last example for today. So today we considered principal part of the function and asymptotes, finding asymptotes using the limit of the function, asymptotes of the function, especially vertical asymptotes and oblique asymptotes. And we have one more type of asymptote. This is horizontal asymptote. It is limit x tends to plus minus infinity, f of x equal to just number L, for example. And this one we call horizontal asymptote of the function. In this case, we don't have any horizontal asymptote because the limit just f of x, x tends to plus infinity, this is infinity. That's why we don't have any horizontal asymptotes in this example. And in previous ones also, we don't have horizontal asymptotes. The next time we will continue our topics. Thank you for your attention.